If you know the position an object moved from its original position, its displacement, which is the distance moved in a specific direction, the rate of change of its displacement known as its velocity, the rate of change of velocity known as acceleration, and the period of the motion, which is the time it took to change its position, we can say a lot of things about the motion of the object. The position of this ball is represented by x. The displacement is represented by s and measured in meters. Its velocity is represented by v and measured in meters per second, and its acceleration is represented by a and measured in meters per second squared. So theoretically, everything that needs to be known to classify the motion has been given to us, and we classify the motion of the body based on this given information. If the position does not change, we say the body is said to be at rest. If the position of the body changes at a constant rate and it travels in a straight line, we say the body is undergoing uniform motion because the velocity v is constant. This means the body covers an equal distance for each time interval. If the velocity of the body changes at a constant rate, the acceleration of the body is constant, and we say the body is undergoing uniformly accelerated motion. But if the change in the velocity of the body in a period t1 is different from the change in velocity in a similar period t2, we say the body is undergoing non-uniformly accelerated motion. So we've mentioned 4 types of motion, and every kind of motion mentioned is a special case of what comes after. So non-uniformly accelerated motion is the most general form of motion in one dimension. However, talking about non-uniformly accelerated motion can get really complicated and require knowledge of advanced mathematical techniques to deal with. So what we'll do is we'll just stick with this, uniformly accelerated motion, because it helps us get the most general equations with the least amount of complications. So let's just make a note about uniformly accelerated motion before we go. In uniformly accelerated motion, the acceleration or change in velocity is constant. Now let's go get ourselves some equations of uniformly accelerated motion.